So several students have said that they are struggling with the skill, and I understand that because it is so new from what you did last year, and there's a lot of steps involved. So I'm going to walk through all of the problems on problem set side. Hopefully this will help you get the steps under wraps. You can walk through the steps with me and do this page with me, or you can just check your work as I go through it. This video is probably going to be a little bit longer than most because I am going to walk through all the steps. All right, so the first problem is already set up for us. Remember, we take the digit in the ones place. Sorry about that. We take the digit in the ones place and we multiply it by everything on top. So 8 times 3 is 24. We write down our 4 and carry our 2. And I just realized that this is not going to be enough room for me to work out this problem. So quick change of pace. 1a. 213 times 3, 28. All right, that's going to be a little bit better. Wow. All right, so 8 times 3 is still 24. We write down our 4 and carry our 2. 8 times 1 is 8, plus 2 more is 10. Put down our 0, carry our 1. Cross off our 2 because we did add it. 8 times 2 is 16, plus 1 more is 17. Write it down. We scoot over to our tens digit, which means our answer needs to go in our tens digit, so we have to put a placeholder, 0. We already used this 8, we're done with it. Now we're going to multiply the 2 by everything on top. 2 times 3 is 6, nothing to regroup. 2 times 1 is 2, nothing to regroup. 2 times 2 is 4, nothing to regroup. Now we're done with the 2, we're going to go to our hundreds place, which means we need 2 placeholders. So now I'm going to multiply the 3 by everything on top. 3 times 3 is 9, nothing to regroup. 3 times 1 is 3, nothing to regroup. And 3 times 2 is 6, nothing to regroup. So now I'm going to take my partial products and I'm going to add them. 4 plus 0 is 4. 0 and 0 and 6 is 6. 7 and 2 is 9, and 9 more is 18. Carry the 1. That's 2. 4 plus 2 is 6. 7, 8, 9. And the 6 plus nothing is 6. 69,864. All right. 1b. And if you're doing this on scratch paper, you should also be numbering your work and labeling it neatly. 662 times 372. We take our digit in the ones place first and multiply it by everything on top. 2 times 2 is 4. 2 times 6 is 12. We put down our 2 and carry our 1. 2 times 6 is 12, but plus 1 more is 13. We cross it off so we know we've used it. We're scooting over to our tens digit, so we have to put a placeholder. We did our ones digit, so now we're on our tens digit. We multiply 7 by everything on top. 7 times 2 is 14. We put down a 4, carry our 1. 7 times 6 is 42, plus 1 more is 43. We put down our 3, carry our 4. 7 times 6 is 42, plus 4 more. Oop, forgot to cross this off when I added it. 7 times 6 is 42, plus 4 more is 46. 46, because there's nothing to carry over. There's no digit up here to carry over to. So we just write the whole thing down. We finished our tens place, so we're going to go to our hundreds digit, which means we need 2 placeholders. 3 times 2 is 6. 3 times 6 is 18. We put down our 8, carry our 1. 3 times 6 is 18, but we have 1 more, so that's 19. Then we take our partial products and we add them together. It is very important that you line everything up very neatly. So this is 4, this is 6, that's 6 and 6 is 12. 6, 7, 8, and 8 and 8 is 16. 9 plus 1 is 10, plus 4 more is 14, and 1 plus 1 is 2. So 246,264. And if you are struggling to keep everything in line, this is a strategy that you could use. So I'm going to take some lined paper and I'm going to turn it this way. Okay, so for 1C, I'm going to do it on this lined paper just to show you what I'm talking about. So 1C, so you would use these columns to put a digit in each column. So 739 times 442. All right, 2 times 9 is 18. We put down our 8, carry our 1. 2 times 3 is 6, plus 1 more is 7. 2 times 7 is 14. We're done with our ones place, so we put a 0, so we can go to our tens place. 4 times 9 is 36. 4 times 3 is 12, plus 3 more is 15. 12, yeah, 15. 15, we added that in. 4 times 7 is 28, plus 1 more is 29. 29. So are you seeing how these columns, these lines here, will give you columns to keep everything in order? We've done our tens place, so we're going to our hundreds digit, so we put down 2 zeros. 4 times 9 is 36, put down a 6, carry a 3. 4 times 3 is 12, plus 3 more is 15. 4 times 7 is 28, plus 1 more is 29. And then we take our partial products and add them together. This is 8. 7 and 6 is 13. We carry over our 1. 4 and 1 is 5, plus 5 is 10, plus 6 is 16. 9 plus 1 is 10, plus 1 is 11, plus 5 is 16. 2 and 1 is 3, plus 9 is 12, and 1 and 2 is 3. So 326,638. So if it helps you to use paper like this and turn it sideways, you can absolutely do that. Miss Bridges just prefers plain white paper, so I'm going to go back to the plain white paper. So that was 1C. We're going on to 1D. 807 times 491. This should be pretty easy because we have a 1 in the ones place. Yay! 1 times 7 is 7. 1 times 0 is 0. 1 times 8 is 8. Sweet. We scoot over to our tens digit, so we put a 0 in the ones place. 9 times 7 is 63. 9 times 0 is 0. Plus 6 more is 6. 9 times 8 is 72. We've done our tens digit, so we're going to our hundreds place. We put 2 zeros. 4 times 7 is 28. 4 times 0 is 0, plus 2 more is 2. And 4 times 8 is 32. Oops, y'all couldn't see all that. We add our partial products. This is 7, this is 3, 8 and 8 is 16, 19, 20, 21, 22. Plus 6 more is 22, 2, 4, 6, 7 and 2 is 9, and 3 and nothing is 3. 396,237. All right, 1E. 1E. Ooh, a 4-digit number on top. 3,502. 656. 6 times 2 is 12. Carry our 1. 6 times 0 is 0, plus 1 more is 1. 6 times 5 is 30. Put a 0. Regroup the 3. 6 times 3 is 18, plus 3 more, 21. We've done our ones place, so we're going to put a 0 as a placeholder and go to our tens digit. 5 times 2 is 10. We put a 0 and carry our 1. 5 times 0 is 0, plus 1 more is 1. 5 times 5 is 25. Put down a 5, carry a 2. 5 times 3 is 15, 16, 17. 17. We're done with our tens place, so we're going to go on to our hundreds place. We need 2 placeholders. You might be like really confused right now and be like, oh no, Miss Bridges, you put 2 placeholders the last time. Why are you putting 2 more? Well, remember, we only put 1 placeholder last time, but it just so happened that 5 times 2 was 10, and that's why we have that other 0 there. It is still correct. 6 times 2 is 12, so we put down a 2 and carry a 1. 6 times 0 is 0, plus 1 more is 1. 6 times 5 is 30, so we put down a 0 and carry the 3. 6 times 3 is 18, plus 3 more is 21. And we add our partial products. This is 2, this is 1, this is 3, this is 7, this is 9, this is 2, and this is 2. 229,312. Now, a problem that I see often is students will get all of this hard multiplication correct, and when they go to add, they'll get their adding wrong. Usually because everything's not in nice, pretty little rows. So, like I said earlier, you might want to use that line paper turned sideways. All right. 1F says 4,390 times 741. 1 times 0 is 0, 1 times 9 is 9, 1 times 3 is 3, 1 times 4 is 4. We're done with our ones place. We didn't have any regrouping. Woohoo! We're going to put a 0 as a placeholder. And then 4 times 0 is 0. 4 times 9 is 36. 4 times 3 is 12. Plus 3 more is 15. 4 times 4 is 16, plus 1 more is 17. We're done with our tens place, so we're going to put down 2 zeros as our placeholders. And 7 times 0 is 0, so we need another 0. 7 times 9 is 63. Yeah, 63. Put down a 3 and carry our 6. 7 times 3 is 21, plus 6 more is 27. Put down a 7, carry our 2. We added that in. 7 times 4 is 28, 29, 30. We add our partial products. This is 0, 9, 9. 5 plus 4 is 9, plus 3 more is 12. 7 and 7 is 14, plus 1 more is 15. 1 and 1 is 2, and 3 and nothing is 3. 3,252,990. 1G says, ooh, this is a good one, yay. Okay, so it says 530 times 2,075. Now, it is so much easier to put the smaller number on bottom, and you are allowed to do that in multiplication. You're also allowed to do it in addition. You are not allowed to do that in subtraction or division. But in multiplication or addition, you can multiply or add in any order and still get the same answer. That's the commutative property. Commutative property of addition says you can add in any order and get the same answer. For example, let's take a little sidebar here. If I added 3 plus 5, I would get 8. If I added 5 plus 3, I would get 8. Commutative property of addition. Commutative property of multiplication says you can multiply in any order and get the same thing. 3 times 5 is 15. 5 times 3 is 15. So you can flip them around in addition or multiplication. And since it is easier to put the larger number on top, we're going to take letter G and we're going to put the larger number on top. 2,075 times 530. All right. Our ones place is a 0. 0 times 5, 0. 0 times 7, 0. 0 times 0, 0. 0 times 2, 0. Lots of zeros. We're going to cross that off because we've done our ones place, and we're going to move to our tens digit. We're going to put a 0 as our placeholder. 3 times 5 is 15. Put down a 5, carry your 1. 3 times 7 is 21, plus 1 more is 22. We added that in, make sure we cross it off. 3 times 0 is 0, plus 2 more is 2. Cross that off. 3 times 2 is 6. We've done our tens digit. We're going to go to our hundreds place, so we need 2 placeholders. 5 times 5 is 25. 5 times 7 is 35, plus 2 more is 37. Put down a 7, carry our 3. 5 times 0 is 0, plus 3 more is 3. And 5 times 2 is 10. We take our partial products, add them together. 0, 5, 7, 9, 9, 0, 1. 1,099,750. All right, letter H. 1H, 4,004 times 603. 3 times 4 is 12. Put down a 2, carry a 1. 3 times 0 is 0, plus 1 more is 1. 3 times 0 is 0, nothing else to add, so it's just 0. And 3 times 4 is 12. We're done with our ones place. We're going to go to our tens digit, so we're going to put a placeholder. 0 times 4 is 0. 0 times 0 is 0. 0 times 0 is 0. 0 times 4 is 0. We're done with our tens digit. We're going to put down 2 placeholders to do our hundreds digit. 6 times 4 is 24. Put down a 4, carry your 2. 6 times 0 is 0, plus 2 more is 2. 6 times 0 is 0, and 6 times 4 is 24. If we add our partial products, this is 2, 1, 4, 4, 1, 4, 2. 2,414,412. All right, that was 1H, so this is going to be 1I. Again, with 1I, just like we did on 1G, the larger number comes second, but I don't really want to put that larger number on the bottom, so I'm allowed to put it on the top. 3,105, 987. 7 times 5 is 35. Put down a 5, carry a 3. 7 times 0 is 0, plus 3 more is 3. 7 times 1 is 7, and 7 times 3 is 21. We've used our ones place, so we're going to scoot over to our tens digit. We're going to put down a 0 as a placeholder. 5 times 8 is 40. Put down a 0, carry a 4. 8 times 0 is 0, plus 4 more is 4. 8 times 1 is 8, and 8 times 3 is 24. 24. We're done with our tens digit, so we're going to put down 2 placeholders when we move to our hundreds digit. 9 times 5 is 45. We put down a 5 and carry a 4. 9 times 0 is 0, plus 4 more is 4. 9 times 1 is 9, and 9 times 3 is 27. We're going to add our partial products together. This is 5, this is 3. 5 and 4 is 9, and 9 plus 7 is 16. We got to carry that 1. 8 plus these 2 is 10, plus 4 more is 14. 9 plus 1 is 10, plus 4 is 14, plus 2 is 16. 16. 7 plus 2 is 9, plus 1 more is 10, and 1 plus 2 is 3. 3,064,635. Oh, y'all couldn't see all that. All right, so we have done all the, this is what Miss Bridges calls naked math. I call it naked math because it's not in word problems, it's just a straight problem. Now that we've done the naked math, we're going to move on to the word problems. If I can slide my paper over here. So it says each container holds 1 liter 275 milliliters of water. How much water is identical to 509 identical containers? Find the difference between your estimated product and your precise product. I am not worried about your estimated product. What you do need to know is 1 liter is 1,000 milliliters. So if we have to make this all milliliters, it's 1,275 milliliters. And we have 509 identical to containers. So we're going to multiply that by 509. All right, so now that I know the problem that I need to work out for number 2, 1,275 times 509. 9 times 5 is 45. 9 times 7 is 63, plus 4 more is 67. Added that in. Oh, y'all can't see all that. 9 times 2 is 18, 19, 20, 21, 22, 23, 24. Added that in. 9 times 1 is 9, plus 2 more is 11. We've done our ones place, so we're going to scoot over to our tens digit. So we put down a 0 as a placeholder. 0 times 5 is 0, 0 times 7 is 0, 0 times 2 is 0, 0 times 1 is 0. We've done our tens digit, so we're going to scoot over to our hundreds place. So we're going to put down 2 placeholders. 5 times 5 is 25, so we're going to put down a 2. We're going to put down our 5, carry our 2 for 25. 5 times 7 is 35, plus 2 more is 37. 5 times 2 is 10, plus 3 more is 13. 5 times 1 is 5, plus 1 more is 6. We're going to add our partial products. This is 5, 7, 9, 8, 4, and 6. So out of how many? 609 identical containers, they would have 648,975 milliliters, because that was the question, was how many milliliters. All right, so number 3 says a club had some money to purchase new chairs. After buying 355 chairs at $199 each, there was $1,068 remaining. How much money did the club have at first? This is a multiple step problem. First it says 355 chairs at $199 each. Each means I'm going to multiply the chairs by the money that they cost. So 355 times $199. That's the first thing I'm going to do. 355 times 199. 9 times 5 is 45. 9 times 5 is 45, plus 4 more is 49. I added that in. 9 times 3 is 27, plus 4 more, 27, 28, 29, 30, 31. Added that in. We're done with our ones place. We're going to scoot over to our tens digit, so we use a 0. 9 times 5 is 45. 9 times 5 is 45, plus 4 more is 49. 9 times 3 is 27, plus 4 more is 31. We've used our tens digit, so we're going to scoot over to our hundreds place, so we put a 0, 2 zeros as our placeholder. 1 times 5 is 5, 1 times 5 is 5, and 1 times 3 is 3. We add our partial products. This is 5, 14, 9, 10, 11, plus 5 more is 16. 3, 4, 5, plus 5 more is 10. 3 plus 3 is 6, plus 1 more is 7. 70,645. But we're not done. This is how much the 355 chairs cost. The story said, the problem said, after they bought all these chairs, this amount of money was remaining. So if they spent this much money, and this much money was remaining when they were done, we need to add these two together to see how much they had at first. So our second step is to take 70,645 and add 1,000. We want to make sure we line everything up. 1,068. 8, 9, 10, 11, 12, 13. 6 and 4 is 10, plus 1 more is 11. 6 and 1 is 7. 1 and 0 is 1. 7 and nothing is 7. So at first, they had $71,713. All right, number 4. So far, Carmela has collected 14 boxes of baseball cards. Each box has 315 cards in it. Each. I'm going to be doing some multiplication. Carmela estimates that she has about 3,000 cards, so she can buy 6 albums that hold 500 cards each. Will the albums have enough space for all of her cards? Why or why not? All right, so we're going to answer 4A first. So she has 14 boxes with 315 cards each. So we need to know how many cards she has. So we're going to multiply 14 times 315. Now, remember, the smaller number on bottom is what helps the most. So instead of putting 14 on the top, I'm going to put 14 on the bottom. Go to my scratch paper here. This is 4A. 315 times 14. 4 times 5 is 20. 4 times 1 is 4, plus 2 more is 6. Added that in. 4 times 3 is 12. We've used our ones place. We're going to go over to our tens digit, so we're going to put a 0. 1 times 5 is 5. 1 times 1 is 1. 1 times 3 is 3. We add our partial products. 0, 11, 2, 3, 4, 3, 4. So 4,410 cards is what she has. That doesn't answer the question. Let's go back to the question. She estimates she has 3,000 cards. Well, her estimate was off, but we'll talk about that later. She buys 6 albums that hold 500 cards each. So 6 albums, 500 cards each. We're going to multiply these together to see what her albums will hold. So 600 times, is that 5? That's a 6. Okay. 600. Miss Bridges just went back and looked at the problem and realized that that is not 600, that is 500. Okay, so let me look at this more closely. Yes, that's 500, and she has 6 albums. So they hold 500 cards each, and she has 6 albums. 6 times 0 is 0, 6 times 0 is 0, and 6 times 5 is 30. So, albums. Her albums will hold 3,000 cards. Our answer to A is still correct. Will her albums hold enough? No, because she estimated wrong. They're only going to hold 3,000, and she has more than 4,000 cards. Our answer to B is still correct. How many cards will Carmela have? She's going to have 4,410 cards. And now we can fix C, which is how many albums will she need for all of her baseball cards. Oops, there it is. How many albums will she need for all of her baseball cards? So each album holds 500 cards, not 600. I read that number wrong. So each album holds 500 cards. We know 6 albums is not enough. Let's see if 7 albums is enough. 7 times 0 is 0. 7 times 0 is 0. 7 times 5 is 35. If she had 7 albums, they would hold 3,500. Is that enough? No. She has over 4,000 cards. That's not enough space. All right, let's try 8. 500 times 8. 8 times 0 is 0. 8 times 0 is 0. And 8 times 5 is 40. Will that hold all of her cards? Well, she's getting closer, but she has over 4,000 cards. 8 albums is not enough. Let's see if 9 albums is enough. 9 times 0 is 0, 9 times 0 is 0, and 9 times 5 is 45. 4,500. Now she has enough space. She has 4,410 cards. She will need 9 albums because 9 albums will hold more than she needs. But she can't have 8 albums because it won't hold all of them. She might have some empty space in some of her albums, but that's okay. She needs 9 albums in order to hold all of her cards. When you answer letter C, you can't tell me the answer is 4,500 because the question says, how many albums will she need? She needs 9 albums. Now that we have done Lesson 8, you can work on Lesson 8 homework by yourself. I will put an answer key out on the Lesson 8 homework. I won't do a video. I'll just do a picture of the Lesson 8 homework side so you can check your work, not another long video. If you have questions, email me.